So, in today's class, we will cover classes and objects. This is something, again, like the last week's class, that you will see in every Python code. Be it a hacking code, be it a code for a game, be it a code for a machine learning algorithm, classes and objects will always be there. Just like functions, these are the most used aspect of Python. Python is an object-oriented programming language. What we mean by that is something I'll explain later in a bit, in a minute. But what we can see, how where we can see the usefulness of classes as objects uh, is in the repetition. Remember in last week's class, or in the weeks before it, even
Taja,
in this.
you're not sharing your screen if you wanted to show something.
No, not yet. I will
Okay.
share my screen when we move to the browser. Right now, I'm just explaining. So basically, from week 1 to week 4, there's one thing that we emphasized quite a lot, and that's the reusability of codes. In the first class, we created some variables, we wrote some lines of code, and then as soon as we moved to the second class, I guess, we started thinking about the repetitions. If we need to repeat something 10 times, 15 times, 500 times, do we need to write all those variables again and again or not? We also started using loops, which helped us prevent some of the repetitions by writing it in the form of the loops. Then in last class, we discussed some functions, which also avoid some of the repetitive tasks that you need to do again and again in your code. You can write one function for it, and then you can just call that function multiple times in a code so that you don't really have to write the whole functionality of that particular function again and again if you need to call that function 10 times, 15 times in your code. So we already saw this very powerful aspect of programming languages, that you can save certain variables, you can write certain functions, and you don't really need to write them again and again if you want the same type of variables, if you want the same type of functionalities. Dictionaries was also another great example of this reusability of the codes. So today we are going to build upon that concept further. And the way to build further upon that is going to be classes and objects. The use of classes and objects lies in reusing both variables and functions together. So remember, dictionaries gave us the reuse of certain variables only. We could put certain variables inside a dictionary, and then we could just keep creating more dictionaries of the same type. If we, for example, made a dictionary of a person who had certain attributes, we could just create multiple variables of that particular dictionary, and all would have the same attributes. We could change individual values of those attributes, and it was a great reusability of storage of data. And then in functions, we saw that there are certain operations that you can perform on certain data types. And if you call those functions again and again, then you can repeat the operations you were performing again and again in the form of a function instead of having to write the whole functionality again. But if we want to combine those two together, we want to create something that can repeat both the storage of data and the operations on those data, on those values. So if we want to combine or merge, storing variables as well as the operations into one thing, that is called a class. That's the whole purpose of a class. It lets you create multiple copies of both variables and functions at the same time. So what's a class? It's a combination of certain stored variables and certain functions. So in a class is like a box in which you can store certain variables and you can also store certain functions. And then you can create multiple copies of this class, and those copies are called objects. So each object that is created from one particular class will have all the same variables as well as all the functions that can be performed on those variables. Any questions so far? Is the idea clear that why do we need classes?
I have a question about reusing the variables. Like we
Okay.
can reuse the variables if we declare them globally. So what's the point of defining them in a specific class?
If you declare them globally, you cannot have different values for them. You will have one value for all the variables. Whereas inside the class, you can assign different values to each of those variables. You will have the same list of variable, but the values will be different. For example, if you're creating a class which has the type called car, and a car has certain variables that it stores and then certain functions it performs. Now, those variables could be speed, acceleration, car make, model, color of it, seats type, comfort level, certain types of variables. Now, each car that you create from this particular class type can have those particular same variables, but you can assign different values to it. For example, car 1 can have a maximum speed of maybe 90, car 2 can have a maximum speed of maybe 150 or even more. So, like the different cars that you create from that class can have their own separate attributes. If you want, you can leave certain attributes constant throughout those cars, and other attributes you can change them, you can modify them. And you can give the same functionality to all those cars. For example, every car moves forward, every car has a steering wheel that lets you move it left or right, or it lets you brake, or it lets you go back. So the functions that you create in those classes will apply to all those cars, but then again, you can make certain modifications per car if you need to. If you need to provide certain special functionality to some function, you can do that for certain objects. Does that
Mhm.
answer your question?
Yeah, I think so. Yeah, like for different instances of the same class, we can
Yeah,
have some variables with different values.
exactly.
Yeah, thank you.
So, with that, let's go ahead and create our first class. It will be a very simple one. We will just call it a class called my class. Instead of calling it my class, we will call it my cars, since we were just talking about cars. And the first variable that we will create inside it will be top speed. So let's create our first variable or our first class. Let's create a code block. Here we create a class, sorry, it's supposed to be with small c, class called my cars, and inside it we say top speed, and we say it is 90. Right now we have created our first car. If we want to create an object from this class, let's go ahead and create another code block for that. I say Sadia's car is equal to my cars with a bracket. Classes work just like functions. So when you want to create an object from a class, you will use these same brackets. Okay? And if I want to print what is the top speed of Sadia's car, I will say print Sadia's car dot top speed. And this will print the value stored in it. Go ahead, copy this code and paste in your compilers. You have the link to this notebook in your chat, right? If not, I will just paste it again so that you can easily copy the code and paste in your compiler.
It is working.
Perfect. What other attributes should we give our car? These are the generic attributes. We can change them later, and I'll show you how we can change them. Let's say top acceleration, and that we can say is 10. What else can we give it? Weight. This is somehow making me think of the Mario Kart, the game, where you have, so many types of cars and
Are
bikes.
you, is that the subliminal message that you want Mario Kart?
Maybe. I didn't like it as much, but I would still like to play it maybe when we have friends over. So wait, what should be the generic weight of this car?
1000.
1000. Okay. What other attributes can we give it other than this? We have top speed, top acceleration, weight. What else? Grip. How much grip should we give it?
0.
Wow. You don't want me to create a good car.
Nope.
Let's print some of these other attributes. Print Sadia's car dot weight, and this will print the weight of it. So far, so good.
I'm unable to access the collab due to some credential problems, I think.
Um, this is a public collab, so you should be able to open it.
Okay, I will copy it from the screen of this room.
You can also maybe check it with GitHub. I'm not sure if it is being updated in real time in GitHub. No, it's not unless I save it there. I will save it in
It's
GitHub.
from the Zoom chat, no problem.
From the Zoom chat, can you click the link and see if you're able to open it?
Like, it's a problem from my end. There's
Oh,
some
okay.
problem in my account's validation. So I will do
All
it
right.
manually.
All right. Try to use maybe a different Gmail account or try to open it in incognito so it lets you sign in again maybe to your Google account or try a different browser maybe. Oh, okay. I've been using Notion too much and I used here the other slashes. What if we want to change some attributes here? For example, I don't like the grip. The grip is so bad on this car. I want to change the grip. I can say Sadia's car.grip and I can assign a new value to it. Let's give it at least grip 5. I don't like the 0 grip. And after that, if I print it, the new grip of Sadia's car is, what happens, what will it print if I execute this whole code now?
I think grep will be 5, although the value in the class is 0.
Yes. So the new grip of my car will become 5. It's important to remember what Basit just mentioned, that this only changes the grip of this particular object called Sadia's car. It does not change the template, my class. So my class is the blueprint. It's the template from which we are creating different cars. So if we create a new car using this template, it will still have a grip 0. For example, let's create Vincent's car.
Sajjad, can you scroll down a little bit?
Yeah, there you go. So let's see what's Vincent's car's grip. And inside the print, I will use the grip of Vincent's car is, and here I will print Vincent's car. So you see, the new grip of Sadia's car is 5, but the grip of Vincent's car is 0. The reason that the new object we created from the same template is 0 is because that we did not, when we change the attributes of one particular car created from this template, it doesn't change the template, it changes that car only. So you see the usability of this, that we can create one template for cars, which is a class, and then we can create 10 or 20 or 100 cars from it, and we can assign specific attributes to each of those cars. Just like in the racing game Mario Kart or Need for Speed or any other car racing game in which you have multiple cars and each car has its own attributes, its own properties. So each car has a base template from which it is created, and then each car has its own attributes, the values that you change and you make it specific to that particular car. Is that clear so far?
Yes, going good.
Perfect. Now, what if we want to assign this value grep while the car is being created here? For example, if I don't want to do it in 2 lines, for example, I created Vincent's car, and then if I want to change the grep, I can say Vincent's car dot grep is equal to, let's give him a good grip, let's make it 5. So when we print, it prints that the grip of Vincent's car is 5. I did it in 2 lines. What if I want to change some other attribute also? Car's weight. I will write another line to change car's weight here, right? So if I want to change all the attributes, I will write as many lines here to change those attributes, right? But if I told you there's a better way, and that better way is called the init function. Init is short for initializer. What does the init function do? The function, well, basically it just initializes the values that you give to it. So whatever attributes you have in your class, the init function can be used to initialize those. Now it has a little bit of confusing syntax, and you might want to come back to this page again and again a couple of times before you get fully comfortable with it. The reason that it works differently than other things is because this is a special function, and that's why it has these underscores with it. It always needs to be written exactly like this. And it needs to be the first line in your class. If you write it anywhere else, it won't work. So the way to write this init function is when you create your class, right after the first line, your second line should be def underscore underscore init underscore underscore, and then the first word always needs to be self. If you don't write it exactly like this, it won't work. This is just the syntax. So whenever you forget it, you can always just come back to this page and you can copy this much from it. Okay?
Mm.
So let's go back to our class where we created it. We said it needs to be the second line of code. So let's go to second line, copy it, after self, comma, and here we write the names of our variables. We say we wanted to change grep, so let's start with grep. Okay, or we can grep here, we can call it just G if we want. I think there is a syntax error in my code. I'm missing the
Collins.
colons at the end of the function, and I'm also at the wrong indent for all those things. So whatever I need to initialize inside the initializer function, I need to write it inside it, and I need to write it with the keyword called self. We say self.grep is equal to G. This will work like a regular function. In a regular function, whatever you pass here as a value gets assigned to whatever we are creating inside here, right? So now we don't need to write grep here. This particular syntax, these two lines of code, will create the same variable called grep, but they will assign the value G here. And if we want to assign a default value to it, we can say equals 0 to assign a default value in case we don't pass it down. The default variables inside the functions work same way in an initializer the way they work in other regular functions, the ones we covered in last week's class. So we don't need to change anything else in our code. If we just run, and to for these changes to be reflected in the code block below, always remember you need to run this code block first, otherwise these changes won't be reflected in your next code block. So after making any changes, we run this code block, then we go to the next code block, and everything works exactly the same way. Now we want to change in this particular code block. Instead of writing this as a next line, we wanted to assign it in the same line. We comment out this one, and let's say here when we are creating it, we say G equals 10. Let's give him even better grip while it was being created, and that will assign the new grip to his car. So this line number 10, has been replaced now by just these three letters. My Google account was signed out in a different tab. Okay, let me just sign in again. Okay. So basically, you can see that now this whole line has been replaced by three letters G equals 10. Make sense? We can do the same thing when we changed my car's grip. So here, instead of doing this, we could have just passed the new grip directly here. So we would not need this line. We would not need to change it since we are creating it. We are assigning it while creating it. So here we can say my car's G equals, let's say 4. Just so it's a different number and we can see the difference that it's printing the right number.
Yes.
So far, so good?
Sadia,
Yeah?
I have one issue.
Yes?
For some reason, my def doesn't work when I write it. Like the def init
Mm-hmm.
doesn't, like the def doesn't highlight itself as blue at all.
Do you have the two columns here and are you writing it at one tab level?
Yes.
Then I will copy this code to the chat and you can just clear your full block and paste it to see if it works.
Okay. Now it works.
Perfect. There can be tiny syntax mistakes, that's absolutely fine. I make them tons and tons of times. It's absolutely normal. The most recent example being when I just forgot these colons after def. So now we saw that, okay, we can pass specific attributes using the initializer function to all these things. So let's say we want to change the top speed also inside. We want to make it an attribute that we are able to change while create, or we are able to assign while creating our objects. So whatever we want accessible while creating the objects should be passed down inside the initializer function. So top speed, let's call it TS, and let's give it the default value of 90. And now we can say self.topspeed instead of top speed only. And equal to 90 gets replaced by
Yes.
whatever value we pass in TS. Make sense so far? Let's
Yeah.
say I want all the attributes to be created this way. So next one I will create will be top acceleration. Let's call it TA. Let's give it the default value of 10. And I do the same thing. I put a tab, I write self, and instead of giving it a constant value 10, whatever we pass down using TA goes there. Let's do the same thing for weight. Self.weight, let's call it W here, and let's give it the default value of 1000. And here instead of passing 1000 we pass W. It's very important to pass these letters here instead of the constant values, because if we don't say self.grip equals G, if we pass a constant number here, then it won't get the new value that we assign while creating the functions. For example, if I did not write G here, then when I say G equals 4 here, 4 won't get assigned to the object called Sadia's car. Is that clear?
Yeah.
Okay, so here we need to use these names that we just used in our initializer, the variable names that we just used here. So all of my attributes can now be created using this particular syntax. So let's say I want to create Sadia's car with G equals 10, TS equals, instead of 90, I want to make it 100. TA, I want to make it, let's say 5. What else? W, I want to make it 900. And uh, Vincent's car, when I create it, I want to make G equals 10. What else I want to change about it? Let's say I only want to change TA. So TA, instead of 10, I want to give it maybe 9. And let's rerun the code. Did I run the upper code block? First, I need to run the upper code block and then I can run this code block. And we can print all the attributes now. So the grip, the attributes, I can say here, the attributes of Sadia's car, and here I can list them one by one. I can say, what was G for? Grip, grip, and I can leave these brackets for grip. Let's say I want to name them here just to prevent confusion. After grip, what's the second attribute we want to print?
Top speed.
Top speed. Okay, top speed. Sorry, top speed. Let's call it here S maybe. What else I want to print? Top acceleration,
Mm.
let's just call it A here. When I print here, I will specifically assign what each letter is. So G equals Sadia's car dot grep. I should probably have gone to next line. Let me see if I can at least here. You cannot see my screen anyway. Okay, so there's no point. Anyways, I'm just assigning these values. I will show you in a second. Sadia's car dot speed or top speed, sorry. And the last one is A equals Sadia's car dot top acceleration. I'm bringing them all back to the same line. There is a way to break the code into multiple lines. I just forgot it right now. So I will show you the code in 2 lines first so you can read what I just wrote and then we will execute it. It might just be this. Does it work like this? Oh yeah, it works like this. So you see here, I just printed these attributes for my car. If I want to print the same ones for Vincent's car, I will do the same thing to check his car's attributes. So if I just take this print statement and change the names here to Vincent and also change the name here. Wait, where did I go? So now we have the attributes from both cars. For my car, we assigned the grip 4. We saw the grip is 4. We assigned top speed 100. We see that top speed is 100. We assigned the acceleration 5 and we see that top acceleration is 5. We did not print weight, so the weight is not printed. For Vincent's car, we assigned the grip 10, which is 10. We assigned top acceleration 9, which is 9. Why is the top speed 90? For Vincent's car, why the top speed is 90? I did not say here, I only gave the grip and the acceleration. I did not give any value for top speed. So why is it 90?
Maybe the default value in the class.
Absolutely. If we go up and we see here that the top speed by default is 90. So when we are creating our objects, if we don't explicitly specify the value of certain attribute, it gets the default value. Make sense?
Yeah, got it.
Okay. So far, we only created variables. I said the usability of classes and objects is that you can repeat both attributes and functionalities inside the classes. So inside a class, we can create now other functions. Just like we created a def at this level, which is a function, which is the default initializer function, we can create other functions on the same tab level. We can say def, what functionality do we want to give to all cars? What functionality do we want to give it?
Vincent's turn to say something.
Vince, what functionality do you want to have every car? Like, what does every car do?
They do backflip. There you go.
Backflip. Okay, so let's call it backflip. And in backflip, if we don't want to define the specific functionality of backflip yet, we can just write the keyword pass, and we can write other functions here. The keyword pass, you need to write it because you cannot just leave any function empty. If you want your code to still work, if you're testing, you can use the keyword pass when you're just leaving this function and you think that you will come back to it when you know what's the functionality of backflip and you're going to define the functionality here. Another function that you want to create maybe would be turn, and we say pass. Another functionality can be accelerate,
Hello, Edu.
and the functionality can be pass. So now, so far we don't know how each of these functions work, but these are the functionalities that we want to give to each of these cars. So how do we give these functionalities? For these, we need the position, the initial position of a car, and then we also need to know a map over which they are moving. We need to know their x and y coordinates so that when they turn, we know what are their new coordinates. So for that, let's create two attributes called self.x, which is the x position or x coordinate. Let's say all cars start from 0, 0. So we don't need to assign them here in the initializer since we are saying that, okay, all cars will always start from 0, 0. These values will change when we call any of these functions, turn or accelerate or backflip. These will change and these will determine the new x and y position of these cars. So for example, if I say accelerate, accelerate will do what? It will not turn the car. So the y position, okay, how we define x and y. Which direction is x and which direction is y for you guys? Horizontal or vertical? How do you define your coordinates?
Y for me is always vertical.
Y for you is always vertical. So let's
Yeah,
go with
same.
that. This means that when we call the accelerate function, only y will change. X should not change because x is the horizontal position of your car. So this we can say self.y, it will change, and by how much will it change depends on the particular acceleration or top acceleration of the car. So we can say self.y will become self, the older self.y plus self dot top acceleration. Why is there a self not defined? Oh, I made another mistake, and I will just show you in a second. When we are defining other functions inside, remember what I was saying about keyword self here, that if you define your initializer function without the keyword called self, it won't work. Well, that is true for all the other functions as well. Any functions that you define inside a class also need to have this keyword called self
Self.
to be able to access. Any questions? Someone was saying something?
No, no, no.
Okay, so this is the mistake I made in my code. I forgot to put self in my functions.
But the same keyword self in each and every function, right?
Each and every function. So let me just copy the keyword self and I will put it in each and every function. Every function can have its own inputs too, but they come after self, just like this. Just like in the initializer, the first keyword is always self, and then you put other functionalities that you want to use inside that function. So same is true for all of these functions. You have to write the keyword self at the beginning of each of these functions. So right now our accelerate function is defined because it changes the new position, it changes the position of the car. Just to test the functionality, we can say the new position of the car is this and this. And we can print the self.x and self.y of this car. So how do we call these functions on these cars now? For example, first things first, let's run this code block so this functionality is stored in this class. How do we call these functions on these cars? Let's say on my car, this is how my car was created. This is how we printed some of the attributes, top speed, weight. Now I want to call the function which accelerates it. I can say Sadia's car dot, just like I was accessing some of the attributes, I can also access functions. And you can see that in on your screen here. I will just do that again so you see it more clearly. As soon as I click dot, it shows you a list of everything that can go after this dot here. So grip, top acceleration, weight, x and y, those are the attributes, the variables. And the other ones, the ones that have this little purple box, are the functions that you can call on this particular object. So far right now I want to call accelerate function because that's the only function defined for my car right now. I'm going to comment the rest of the code so we only see the code block up to here. What happens when I run this code block? What's the expected output?
Sorry, could you repeat the question, please?
What is the expected output on the screen by running this code?
New coordinates.
Yes, absolutely. Or an error. Let's see what's the error. Sadia's car dot accelerate.
String. Not.
Oh, I put this is a syntax error. Instead of dot format, I put comma format. You see here, by calling
Mm-hmm.
this function, we use dot here. So I used a comma while defining it. And since I made a mistake in block 1, I need to run block 1 first. Only then I can run my second block. And that fixes the error. So first we printed on line 2 top speed, then we printed the weight, and then we called this function, which is Sadia's car dot accelerate. So when the code comes to line 4, it sees my car's attributes. My car's top acceleration is what? TA is 5, top acceleration. So the initial position of car was 0, 0. When I accelerated it by calling the function accelerate, the new position of the car becomes 0 and 5.
5.
So far so good?
Yeah, and now I understand what model.fit was doing.
What?
In my previous semester,
Mm-hmm.
I was working in machine learning code. So
Okay.
model.fit and model.predict.
Oh, okay, okay. So you were
Yeah,
calling the fit function and you were calling the predict function. This is how functions are called on objects. So you had an object called model, and then you were calling the function fit on it, and you were
yeah,
calling the function predict on your object called model.
yes.
This is how classes and objects work in Python. And that is basically everything you need to know to be able to code anything, any kind of code in Python. Right now, after this code, we have covered everything that I know about Python and everything that you need to know to code anything. I will show you I will prove this to you. So, any questions so far about anything from the beginning of the course until now? If you have any questions, let's discuss those first, and then I'll show you what I mean by this is everything you need to be able to code anything. Questions about today's class, any previous class, about these classes and objects, anything. Is everything clear?
I'll have to watch the recording to answer that question.
Okay, no problem. For
I'm
everybody
sorry.
else, is everything clear?
Yeah, we
Kinda,
can move forward.
I just getting an error, but I think it's I did a syntax error, and that's all.
That's okay. I'll help you with that. I'll look at your code again. No problem. But conceptually, is everything clear? Why do we need classes? What's their
Yep.
usefulness? What are the attributes here? What are the
Mhm.
functions here?
Yes.
Perfect. Then what I mean by this is everything you need to be able to code anything in Python. And why was I saying that I will prove it to you? This is my GitHub library, GitHub repositories, and there should be some codes here. Let me see my repos. Maybe more for cognitive radio. Yes, this is the code for my last paper that I published. My most recent paper that I published in IEEE. What the journal? I think Internet of Things journal. This is a machine learning code in which I have environments, agents. This is a folder in which I'm just storing the images. Here I'm just storing my older variables for reuse. Here I'm creating a network and some other different parameters, some other folders for different types of codes. Ask me to open any of these folders and any of those codes, and I challenge you to point out any code statement that you don't understand, or any code statement that uses anything different than what we already covered in this class. The most complex one among these are agents and environment. Environment creates an environment, and agent basically is a deep reinforcement learning agent that interacts with that environment and learns from it. So I'll show you both of them. Let's go to the agent maybe. This is my code. In today's class, we learned how to create classes. So this is a class called agent that I created. Let me just see if I can. Oh, I need to open zoom it for it to work, because I think you were not able to see my code fully, but you should be able to see it now. So you see here I created a class called agent. I used the function init. The first keyword is always self, and after that I have a number of parameters in it. Learning rate, gamma, number of episodes, epsilon type, horizon, action space, number of agents, channels, all these parameters. But essentially the idea is same. I'm assigning those values to some variables inside my class with the self keyword, just like we learned today. Then I'm creating some functions. So my first function is create epsilon function. Inside that I'm using if, else if, those things. Then I have another function after it, but I don't think you will be able to see it on screen yet. I will scroll down and show you. Now, this one is my second function called act. This function basically defines how the agent takes action. The next one is update, which basically defines how the agent updates its queue tables and stuff. I have another class called DQN agent, deep queue learning, deep queue network agent. So basically, this is a very complex machine learning code that is for an actual paper, a published paper. But you won't find anything that you haven't learned so far. Maybe something, one or two keywords related to some specific functions, but most of the things will be everything that you have already learned in this course. Let's check another folder, the one I was saying about the environment. So environment.py is another code, and in that one also, I created a class, I created some functions, I used some for loops. Here you can see on your screen I'm using for I in range self dot number of PUs. So I'm looping over number of PUs here and I'm doing some functionality inside it. I'm calling some other functions inside this for loop. For example, PU1 dot create TX pattern. This basically calls a function called create transmission pattern on this object called PU1. I have some other functions called reset, step. So these are all my functions, but essentially I'm only using functions, for loops, if else statements, classes, and objects to write this complete machine learning code. That is what I mean by you have learned already in this course everything you need to write any kind of code you need in Python. This is a machine learning code. This is a working code for a published paper that I'm showing you right now. And it only uses all the commands that we already learned in this course. So that will be all from my side. Take care, have a nice day, and I wish you learned something from this course.
Thank you so much, Saja.